Our next speaker is Dr. Chao, a learning scientist at the Concord Consortium, and she'll be talking on teaching AI in algebra class, applying linear functions to build sentiment analysis models.
Can someone help me to transition? Okay. Where's the? Okay, good. Okay. Thank you very much. Hello, everyone. My name is Chao. I'm the learning scientist from the Concord Consortium. I just realized that a lot of people don't know about Concord Consortium. We are a R&D institution, non-for-profit, and we create a lot of instructional technology and curriculum for STEM education. And all of the resources are funded by National Science Foundation and the Department of Education, so it's free. So anyone needs those resources can come up to me later. So I'm going to talk about how to teach AI in math class, in algebra class, and especially looking specifically at linear function, using that to build a simple sentiment analysis model. And why do we want to do this? I don't think I need to reiterate the importance of bringing AI into school. A lot of people are working on AI literacy education these days. It is important for young children to learn about how AI works and how to build them from early on. And there's many approaches that people are trying. We have heard some standalone AI courses today, and also there's a trend putting AI units into existing computer science courses, and also AI after schools. There's a lot of many after school opportunities popping up in the market. And we chose a relatively challenging route, which is try to put AI topics into core courses that all students take in their classes, like their math class, their English class, their social studies classes. The main reason for doing that is because that's where all the students are. They're required to take those classes. Nobody get to, elect into computer science classes. If you go to those places, usually you have certain type of students, and then many other students will opt out from those classes. The other reason is we wanted to mobilize all the teachers in school to jump on board to teach about AI literacy together. It's not just the job of a computer science class, computer science teachers or technology teachers. All teachers should contribute to this mission. And when we put AI into English class, math class, social science class, it really conveys a very clear message that AI is interdisciplinary. It's not just a computer science thing. It actually requires a village of computer scientists, mathematicians, domain knowledge holders, and the people who really know the problem they need to solve it together. And then lastly, we wanted to make sure that whatever we bring into those classes can enhance the core subject matter learning on its own. And this is especially matter for the adoption among these math teachers and English teachers, because if it doesn't make sense for their classroom, they would not use it. So you're looking at the kind of the set of curriculum modules that we bring into school as a whole set of resources. And together, today I'm just going to focus on the math module, where we really position students as the mathematical modeler. And the question we have students to ask is, how is knowledge represented using mathematics, using numbers and variables, operations that you know, and how is learning, meaning machine learning, made possible using mathematics? And yesterday I presented a module for the ELA module where we explore generative AI, how AI can generate text. So if you're interested in the slideshow, I can share that later. So the main challenge we give students is to create a sentiment analysis model. Here's a very simple one. the model should take an input, which is a customer review. Say, this is the best ice cream I've ever had, or something like that. And then be able to predict a score from 1 to 5, representing the positivity or negativity of it, right? 1 being very negative and 5 being very positive. We all have done something like this when we're giving reviews on Amazon or different places. So this is the model that students will build together. And the first thing we did was we gave them a pre-built model. Someone else built a model for them to explore. So when you're coming onto our curriculum page, you'll see 2 examples where there's some reviews and then some predicted score predicted by the model. And the student will be able to enter their own custom reviews on the 3rd line and then hit enter and then see the prediction by the model. They can do this many, many, many times to test out how this model works. And then we ask them to think about, how would you build such a model? What do you think, how this model works? And a lot of them already come up with notions of looking at keywords, and maybe different words have different weights. So that brings us to the key question. Can we use numbers, use mathematics to represent our human experience as customers being happy or not happy about certain places we've been to? So we give them this task, and the task is, we have 10 words up there. You can see excellent, mediocre, bad, fine, awesome. And can you place those words on a number line? So the number line in the middle is 0, right? Very neutral. And on the left, -1 means very, very negative. And then on the right side is 1, very, very positive. So think a little bit about where you would put all these 10 words. Let's say awesome, where would you put it? And then good, where would you put it on the number line? So everyone may have a different answer, and this is where I might put them, put awesome into around 0.9, being very positive, and good, put it on around 0.4. But everyone will have a different answer, right? In your classroom, students started to do these, look at each other's ratings of these words, and they will see a distribution of their rating using numbers to represent the same words differently. And if you look at some statistical results, this is a survey results from Inside America. And people really have different opinions about how numbers should represent words. For example, the word good, you're seeing like 3 peaks here. Some people would put it around 0.2, and some around 0.5, and some around 0.9, right? Depends on how you use it. You would say good, or good, or good, right? That all feels different. So the meaning of the word really change a lot depending on the social context and the usage context. So that says something about the limitation of mathematics representing human experiences. But regardless, we can start to build some models to represent the totality of sentiment inside a customer review. We can use this equation, like y equals to x1, meaning it's a feature value. Maybe you have the word good in it, and that can be represented as 1. And then the W1 can be the feature weight, like the polarity of that word, the influence of the word good on the total sentiment. And you can combine them using multiplication, making a weighted feature value. And we may have many words in customer reviews, bad, awesome. So combining all of them together, we get the weighted sum, and that's the basis of us making any predictions or making any classifications. So now it comes down to, we already built the skeleton of a sentiment analysis model. Now we can try a mini challenge together. If you're interested in doing on your own, here's a URL called tinyurl.com, 6-word model. Once you enter it, you will be prompted to make a copy of a spreadsheet. If you wanted to do it on your own, it's super fun. But if you just wanted to watch me struggle with it, you can do that too. So you'll see something like this. And this is basically a sentiment analysis model using, it's a linear threshold model behind the scenes, but we have kind of unboxed it so the student can see the computation within. The only thing that we need to do is to fill up this blue box. That's what our model's content are. We need 6 words, and also we need to assign the feature weight of these 6 words so that in the purple box, your model can make correct prediction of the sentiment of these 10 reviews. Okay? So with that in mind, let me try something first. I just feel like maybe we should put the word good in it and then give it 0.4 weight. So now you're seeing some yellow cells popping up saying 1 here. That means this review has the word good in it. And then here, this is the weighted feature value. And then based on that, the model have made the decision that the sentiment of this review is positive, and compare with the true sentiment, the prediction is correct. So we have now 2 correct prediction, but 1 incorrect prediction. So what should we do next? Shall we try a different word? What word do you want to try? What is it? Very good. Let's try a single word. Single word. Yeah. So how about we take a look at this one? Because this one we got it wrong, right? It says incorrect. Let's read it. The ice cream was good, but the service was bad. Okay. So do you see something that we can try? Maybe we can put the word bad in it. But then in terms of the feature weight, we can give it a negative 0.5. So that will really balance out the influence of the word good. So now we have bumped up the correct rate to 50%. That's pretty good. But we still create another troublemaker here. And this one says the ice cream shop is great. There's nothing bad I can say about it. Okay, so in order to address this error, what would you do? Use your... Okay, so I heard the word great. So what feature value would you give it? You can shout it out. What? Should it be positive or negative? Positive. Do we feel like maybe positive, I don't know, positive 7? Let's give it a try. Okay, so we fixed that one. We bumped up the accuracy level to 70%, but we still have some incorrect and unsures. So in the classroom, students will spend more time doing this. And I would say within like 15 or 20 minutes, they'll figure it out and really experience this kind of manual building of the classification model, sentiment analysis model. But they will also realize that this is a quite tedious process, selecting word and then setting and always tweaking those feature weight. And that will bring us to the next topic. Can we create a machine learning algorithm to do these tweakings? That's basically all the things you do manually, we can have a machine learning model to do that. So coming back to our slide, the next thing we bring to the students is to think a little bit about how machine learning algorithm may do this. So you can think about a very simple case where we only had 2 variables, 2 features, the word good or word bad. And basically we're creating a 3-dimensional space with these 2 variable equation. And then again, you can try this on your own. There's a tinyurl.com 3D graph searching. And when you come here, you can see this 3D graphing here. We have 4 points representing 4 reviews in this 3D graph. And then you need to find a surface that can fit all the 4 points. So we can have a starting one. Let's just say z equals to x plus y. And you're seeing this one fit 2 of them. And the student's job is to actually tweak the coefficient and a constant of this linear function to make it work. Let's try something. We can add some coefficient here and keep turning and rotating the surface until it fits all the 4 points. And that will be the surface or the equation or the model that can predict all these 4 reviews correctly. And conceptually, we will introduce this idea of machine learning is searching. You can see that every point has initially have a distance between the point and the surface. That's the error that the machine learning algorithm is trying to reduce. And by turning and rotating that surface to reduce the error, we're able to find the final equation, which is the sentiment analysis model. And in the curriculum, I also expose students to many careers and people in the AI space. And here's the pilot results. We don't have time to go through the results, but you have the paper online you can read. We currently have already finished the revision and implemented the newer version. So if you're interested in the newer version, you can take the link from those, and also you can reach out to me. I can go through those with you. Thank you, everyone.
Thank you, everybody. That's the end of our talks here. I believe there's coffee and other refreshments outside. Thank you so much.